Marginal utility is one of the most important aspects of the utility function that we need to describe. Remember that the marginal function is the slope of the original, so marginal utility is the slope of the utility function. And we've already talked a little bit about what the slope of the utility function should look like, but we want to calculate it here formally and graph it so that we can see that relationship. So we're going to continue with this simple utility function with food, right? And we're going to try to calculate marginal utility. So marginal utility is the slope of the utility function. And to calculate the slope, all we need to do is to take the first derivative. So remember here that the square root of f, that's the same thing as writing f to the 1/2. So whenever I see a square root, I try to write it as an exponent because that makes it a lot easier to take the derivative. So now if I want to take the derivative of f to the 1/2, that's going to be 1/2 f to the negative 1/2, which of course you could rewrite as 1/2 square root of f. That's our marginal utility, and we want to think about what it looks like. So I can see here, because f only takes on positive values, you can't have negative food, that this fraction is always going to be positive, right? It's always going to be bigger than 0. So the first derivative of the utility function is positive, and the second derivative should be negative. We can see that by taking the derivative of the marginal utility function. So now I've got 1/2 times negative 1/2 is negative 1/4 f to the negative 3/2, which of course is going to be a fraction again. And you see the negative here tells me that this is going to be negative, right? Because remember, f always takes on positive values. This is just a inverse root, and then this is telling me that this is going to be negative. So I've got a negative second derivative, which is good because that's going to give me decreasing marginal utility. So let's go ahead and plot our utility function and our marginal utility function so we can see what's going on here. Again, I'm going to just plot these numbers that are easy to take the square root. And utility is the square root of food. So I've got 1, 2, 3. And then my marginal utility is going to be 1/2 times 1 over basically utility, right? The square root of f. So that's going to be, it's not really defined here. We've got 1/2, 1/4, and then 1/6. So I can, this is the same utility function we were using before, so you'll remember it looked like this. It's concave, meaning it has a positive first derivative, negative second derivative. And the consequence is that my marginal utility is decreasing, right? It's positive, but the slope of the marginal utility function is negative. It's a decreasing function. So I've got 1/2, 1/4, and then 1/6. So something like this. So utility and marginal utility. And you can see utility is concave, marginal utility is decreasing, just like any well-behaved utility function will exhibit.